just want to welcome everybody that are sitting here. The president of the university just left, Professor Lily Barak, our dean, and our wonderful, wonderful colleagues that came from all over the world, our students and guests. As you see, I lost my voice, and I will try to save my voice for my second lecture. And Dr. Barzilai, my colleagues, is nice enough to help me, and she will read my opening remark. I wrote it, I promise. So, and I'm sure that she has a much better accent than me, so you will be able to understand it better. So, Miri, thank you very much.
In Zvia's words, we have come together from all over the world for these 3 days to explore reading fluency, how it develops, the neural systems that support it, and how it can be trained. We would like to frame this exploration by considering a wise saying popularized in the Middle Ages, festina lente, or make haste slowly. This phrase encapsulates the necessity of action that is both quick and deliberate. Much of our discussion on fluency similarly revolves around finding the balance between accuracy and speed that enhances instead of impairs reading. Reading too fast may compromise accuracy and comprehension, but then again, so will too slow. It is in that delicate place where all brain systems and linguistic aspects come together in synchrony that we find fluent reading. What then are the neural correlates of this fluency? And how do they differ across impaired and unimpaired populations? How do aspects of orthography and bilingualism influence fluency? How can we best train readers to reach this level of fluency? These are just some of the questions that will be at the core of our discussion over the next 3 days. But perhaps we should begin with a deceptively simple one. How do we define fluency? Definitions of fluency in reading are plentiful in the professional literature. Among these, the most agreed upon definition outlines reading fluency as based on accurate decoding and comprehension that is fast enough to meet the limits of working memory with correct prosody. For years, reading fluency was thought of purely as a dependent variable, affected both by the quality of decoding and by reading comprehension. A revolution in this field occurred in the late 1980s when reading fluency was viewed itself as the independent variable that influenced decoding skills and comprehension. We argue today for the necessity of approaching reading fluency as both an independent and a dependent variable. As a dependent variable, fluent reading reflects accurate decoding and comprehension and can be expressed by the prosody of the vocal output. This is the widely accepted view of fluency. As an independent variable, reading fluency is linked to the rate, time, and speed needed to execute oral or silent output. The central question now becomes, what are the factors that underlie reading fluency, and how do these influence reading skill? Based on numerous studies from our lab, we propose that reading fluency be viewed as an outcome of the speed of information processing in the cognitive system. This means it is influenced by the speed at which the brain systems active in reading, such as visual, auditory, attentional systems, perceive, process, store, and retrieve information. It further means that reading fluency will be dependent upon multiple neurological factors, such as the rate of neuronal circuit activity and the amount of myelin that covers the nerve. Viewing fluency as the independent variable has thus opened the investigation into the multiple factors underlying it. It has further equipped us with a powerful probe with which to understand reading skill. Although measures of decoding and comprehension are frequently used to assess reading skill, they are basically dichotomous in nature. For example, in decoding text, one is either correct or incorrect. Similarly, reading comprehension is often measured according to the number of correct, incorrect, or partially correct answers. In contrast, reading fluency as measured by time is an open-ended measure that is easily quantified and observed. Any minor change in the reading time scale reflects changes in the time and quality of the activation of lower and higher level brain systems. Reading fluency is further indicative of reading habits and skills. and is sensitive to the difficulty level of the text. It may also be influenced by the reader's emotional state and motivational level. Here we suggest that as an amalgam of all these factors, reading fluency be viewed as a monitor of the reading process. Any slowing in fluency can indicate that something has gone awry and the reading must be slowed to try to salvage decoding and comprehension. Likewise, fluent reading indicates that everything is performing as it should and facilitates comprehension. In this way, reading fluency has a pivotal place within the reading process that makes it an excellent candidate for intervention. That is because fluency is influenced by underlying brain systems that are amenable to change, and because changes in fluency in turn influence the quality of reading, training at the level of reading fluency can enhance the reading process. Returning to the idea of festina lente, results from our lab have shown that training of fluency can help achieve this balance between too slow and too fast. In particular, research has demonstrated a gap between readers' reading ability and performance. Most readers are able to read more fluently than they do, and this gap is widest among dyslexic readers. Our work highlights the success of a program that adapts to individual abilities of each trainee and pushes them to adjust their reading speed in increments in facilitating fluent reading among dyslexic subjects. The question of how exactly this training achieves results remains, however, a matter of debate. Two hypotheses have been proposed regarding brain activity changes following training. The first is the normalization hypothesis that states that intervention can assist in correcting the reading pathway by creating a pathway identical to that created naturally among typical readers during reading acquisition. The second is the alternative pathway hypothesis, which takes the view that intervention creates a new reading path among dyslexic readers, one that doesn't exist among typical readers. Whether it is the former or latter, or some combination of the two that explain the intervention effects, is yet to be determined. As is apparent from these brief remarks, we have made exciting steps in the study of fluency and its remediation. But there is still much to investigate and learn. So that is Zvia call to action. May we all enjoy a wonderful and fruitful conference.